precise measurements. Of course, for measurements to be both accurate and precise, the measuring devices must be in good working order. Additionally, accurate and precise measurements rely on the skill of the person using the instrument. The user must be trained and use proper techniques. The precision of a measurement is indicated by the number of digits reported. A value of 3.52 grams is more precise than a value of 3.5 grams. The reported digits are called significant figures. Significant figures include all known digits plus one estimated digit. Consider the rod in Figure 12. The end of the rod falls between 5.2 centimeters and 5.3 centimeters. The 5 and 2 are known digits corresponding to marks on the ruler. To these known digits, an estimated digit is added. This last digit estimates the rod's location between the second and third millimeter marks. Because it is an estimate, one person might report the measurement as 5.22 centimeters and another as 5.23 centimeters. Either way, the measurement has 3 significant figures, 2 known and 1 estimated. Remember that measurements reported with a lot of significant figures might be precise but not accurate. For example, some chemistry labs have balances that report mass to the nearest hundredth of a gram. If you and each of your classmates measured the same copper cylinder on the same balance, you would probably have a group of very precise measurements. But what if the balance had been previously damaged by an object that was too large for it? Your precise measurements would not be very accurate. Figure 12. The markings on the ruler represent known digits. The reported measurement includes the known digits plus the estimated digit. The measurement is 5.23 centimeters. Infer. What is the estimated digit if the length of an object being measured falls exactly on the 5 centimeter mark?
Okay. So the only thing I wrote down on this page was significant figure. I just passed you a handout out. So go get your handout that I just laid on your desk. I'll bring you one. And then I want you to look at the back page. The back page on the right-hand side gives you the rules of sig figs. Okay? While we're going over the next page, what I would like you to do is I would like you to look at that. And if there's anything else that's in the book that contradicts it, I want you to add it. Okay? Right here on this side. Does everybody see this? So what I did is I just took my paper and I folded it because I've got 4 pages on here. And then on the back here is where we have significant figures. If you look on the next page, they give you rules for sig fig. And what I want you to do is as she goes through them, if there's something else that you need to add to our paper, add it.
Problem-solving strategy, recognizing significant figures. Learning these 5 rules for recognizing significant figures will help you in solving problems. Examples of each rule are shown below. Note that each of the highlighted examples has 3 significant figures. Rule 1. Non-zero numbers are always significant. 72.3 grams has 3. Rule 2. All final zeros to the right of the decimal are significant. 6.20 grams has 3. Rule 3. Any zero between significant figures is significant. 60.5 grams has 3. Rule 4. Placeholder zeros are not significant. To remove placeholder zeros, rewrite the number in scientific notation. 0.0253 grams and 4320 grams each has 3. Rule 5. Counting numbers and defined constants have an infinite number of significant figures. 6 molecules, 60 seconds equals 1 minute.
Okay, so let's look at our paper here. on our paper, which one is rule 1? Says here, non-zero numbers are always significant. Which one is it? Do you see it? I don't see it. So I'm going to add it. Non-zero numbers are always significant. And what I'm going to do is I'm going to write the example. 7.3 grams has 3. So I'm going to write that beside it. That's the example it has in the book. That's the example I'm going to put on my paper. Number 2, all final zeros on the right of the decimal are significant. That rule 2 is rule 3 on this paper, correct? So what I'm going to do is beside rule 3, I put rule 2. And the only thing I'm going to do over here is I'm going to write my example, 6.20 grams has 3. Number rule 3, all zeros between significant numbers are significant. That's going to be the rule 1 that's on here, right? So I'm going to put a 3 beside it so that I know that is rule 3 in my textbook. So this is what I did. Before 1, I put 3 because that deals with that rule. And I did the example that's here for that rule. So 0.5 grams have 3 is what I wrote beside it. Just like this. Put it beside 1, correct. Rule 4, placeholders, zeros are significant. To remove a placeholder 0, rewrite the number with significant digits. Is that on here? That is rule 2. So I'm going to put rule 4 beside it. Now what I'm going to do is I'm going to write the example that's beside it. Rule 5, counting numbers are definite constants, have an intimate number of significant figures. That one's going to be rule number 4. So what I'm doing here is I went through, modified what I had. I wrote down the rules from here, and I wrote the examples beside it so I could have it. Is everybody good so far?
For 2, we had 4, right, on our paper?
Correct. So my numbers are 3, 4, 2, 5, and 1. So in my ISM book, I'm going to do, and I would like you to do question number 35. I would like you to do number A, and I would like you to do number D. 36, B, and C. I'm going to write it on the board for you. So on this pair, I want you to do number 35, A and D, 36, B, and C in your book. So write your numbers down, use your rule, and see if you can identify. No sleeping in class. Thank you, sir. I know. Struggle's real today. Okay, we ready? Number 35 says 508.0 liters. By your hand, tell me how many sig figs you think we have. 1, 2, 3, 4, 5. How many you think? Using the rules that you have in front of you. Let's see what you got. Show me your hands. I got one committed. Nobody else is committed. Augustine. How many? Okay, I got another committed. Anybody else got any numbers that committed, or they just not gonna want? They just don't want to be wrong. Now, is this 0 a placeholder? Yes. Is this 0 between two numbers? Yes. So my answer is 4. 4. Now, here we are. Remember how we did before? We were trying to figure out where to round, right? This isn't what that is. This is saying, all right, how many numbers are significant? Does everybody understand why there's 4?
I think placeholder 0 was significant.
So it tells us in our rules that it is, though, right? Yeah, it tells us in the rules that it is because it's a placeholder. So do me a favor, sir. Will you do me a favor? On yours, write that down. Placeholders are significant. And I'm going to write this example down. 508.0 liters. That has 4 sig figs. How about that? Okay. Ready for our next one. D says 807,000 kilograms. All right. Show of hands. How many you think it is? Okay, I got some answers. Now, are these placeholders? Is there a decimal there?
No.
Not placeholders. Is this 0 in between two numbers?
Yes.
Yes. So what do we got? 3. I promise you, if you get this wrong on the test, I'm not going to crucify you. I will not even mark it wrong. I'll just write down the number it's supposed to be. This is hard stuff. Okay, everybody good so far? All right, let's do B. B says 0.000482 milliliters. Now, I can go 2 ways with this. Okay? Since there's a decimal there, I could say 1, 2, 3, 4, 5, 6. I could. All right? But are these leading numbers? Are these leading zeros? Yes. What does the leading zeros say? They're not significant. So, 3. But I also say it could be 6.
I would have said 6.
Because there are a placeholder here, and this kind of shows you where we're going. Because it's not 0.482 milliliters, it's 0.000482.
That could be either or.
I'm going to say the textbook says it's 3. I'm going to tell you I think it's 6. So I'm taking either or. Okay, ready for the last one. Now this one's peculiar because what's going on here? Scientific notation. So what's the first thing we need to do from scientific notation?
Pull that up calculator.
Yeah, let's go find out what the real number is. Yep. What's your calculator say? Same number, right? Does it give you the same number? Mine's in normal mode. When I did it, I got the same number. So, since it's giving me the same number, what do I have to do? Can't use my calculator, so I have to use it myself, right? How many places am I going over? 4. 1, 2, 3, 4. There's my number. Okay. How many significant digits is it? 1, 2, 3, 4, 5. I've got so far, right? So it could either be 5 if you are saying those are leading zeros. If you're saying that's a placeholder, 6, 7, 8. Does everybody agree? 5 or 8. It's a lot. Did you write it down? Okay. Rounding numbers, next page.
Rounding
Let's
numbers.
get to what we know already.
Calculators perform flawless arithmetic, but they are not aware of the number of significant figures that should be reported in the answer. For example, a density calculation should not have more significant figures than the original data with the fewest significant figures. To report a value correctly, you often need to round. Consider an object with a mass of 22.44 grams and volume of 14.2 cubic centimeters. When you calculate the object's density using a calculator, the displayed answer is 1.580817 grams per cubic centimeter, as shown in figure 13. Because the measured mass had 4 significant figures and the measured volume had 3, it is not correct to report the calculated density value with 8 significant figures. Instead, the density must be rounded to 3 significant figures, or 1.58 grams per cubic centimeter. Consider the value 3.515014. How would you round this number to 5 significant figures? To 3 significant figures? In each case, you need to look at the digit that follows the desired last significant figure. To round to 5 digits, first identify the 5th significant figure, in this case 0, and then look at the number to its right, in this case 1. 3.515014, last significant figure, number to right of last significant figure. Do not change the last significant figure if the digit to its right is less than 5. Because a 1 is to the right, the number rounds to 3.5150. If the number had been 5 or greater, you would have rounded up. To round to 3 digits, identify the 3rd significant figure, in this case 1, and then look at the number to its right, in this case 5. 3.515014, last significant figure, number to right of last significant figure. If the digits to the right of the last significant figure are a 5 followed by 0, then look at the last significant figure. If it is odd, round it up. If it is even, do not round up. Because the last significant digit is odd, 1, the number rounds up to 3.52.
Okay, so don't write all this down. The only thing that you need to know is if you need to know if you're looking at the rounding part, you look to the right, right? If it's less than 4, this number stays the same. If it's greater than 6, then this number rounds up. If this is a 5, you look to the next one and follow the rules. These are the couple things that you have to do. So just write this down. Just a couple more minutes and then we're going to be in the lab. Because y'all are going to need to go back there and do a little bit back there real quick. before we do anything else. So just copy down what's on the board for me. Does everybody understand what it's saying? Because I just did it very short. Okay. I'm going to play this while you write.
Addition and subtraction. When you add or subtract measurements, the answer must have the same number of digits to the right of the decimal as the original value, having the fewest number of digits to the right of the decimal. For example, the measurements 1.24 milliliters, 12.4 milliliters, and 124 milliliters have 2, 1, and 0 digits to the right of the decimal respectively. When adding or subtracting, arrange the values so that the decimal points align. Identify the value with the fewest places after the decimal point and round the answer to that number of places. Multiplication and division. When you multiply or divide numbers, your answer must have the same number of significant figures as the measurement with the fewest significant figures.
Okay. 2 things you need to write down, and we're going to go to the left. When you are adding or subtracting, how do you round? What are we looking for? So if you're doing 24.6 plus 37.47, what are you doing when you're adding or subtracting? Yeah, but how are we going to round though? What does it say on here? Look on the page we just got finished here reading, because I know you were writing. What does it say you have to do for the adding and subtracting? Identify the value with the fewest places after the decimal and round. So based on this one, where's my placeholder?
To the right.
It's this 1 digit, right?
Mm-hmm.
So this is 1 digit, and that is the lowest number of places. Okay? How about multiplication and division? What are we going to do with that rule? Says when you multiply or divide your number, your answer must be the same number of significant figures as the measurement with the fewest significant figures. Same rule, right? Both of these have to deal with the one with the smallest number. Okay? Smallest number. That means how many numbers after the decimal. Everybody good?
Yes, ma'am.
Draw a line on your paper, go to the lab.
Yes, ma'am.